To calculate the standard deviation, I'm going to take each of these individual ages and subtract the mean and then square it. So for example, the person who's 17, they are 6.25 years away from the mean. So we're going to take 6.25 and I'm going to square it. The person who is 19 is 4.25 units away from the mean. So I'm going to take 4.25 and I'm going to square that. I'm going to do that for each of the 8 observations. So I end up in the numerator with a sum of 8 squares. I'm going to add those up. And then I'm going to divide here by 8 minus 1 because, again, we've lost 1 degree of freedom, so we always divide by n minus 1, so we're dividing by 7. And then to take the square root of that whole thing to get back to the standard deviation, I come up, if I calculate this all out, with a value of 6.3. What does that value of 6.3 actually mean? So again, this is trying to get at the average distance from the mean. So this is saying that roughly the average scatter around the mean is 6.3 years. Now if you notice, if you look at each individual participant here, like there's a person who's 17. Well, 17 is almost 6.3 away from the mean, but not quite. 19, 21, 22, 23, 23, 23, they're all much less than 6.3 away from the mean. So it's not looking like the average distance from the mean is really anywhere around 6. But we have one person who's really far from the mean. They're 38 when everybody else is in their early 20s or teens. That person is because they're far from the mean, they're having a lot of influence. That person is driving the fact that this 6.3 value is so high. So again, you know, if you're far from the mean, you can have a lot of influence on the variance or the standard deviation. And so that's why that it comes out to be 6.3 there.